All right, guys, welcome back from break. Hope you enjoyed it. Let's see what you remember from before break with some basics of logs, going back and forth between a log and an exponential. Today's lesson, half of it is just solving logarithmic equations, which we've already kind of talked about the basics. So that should not be brand new to you. And then there's a few special properties of logs that we'll discuss also. And as long as you follow them correctly, you should be just fine. Also, everybody all day says pretty easy, so I think you will too. All right, here we go. Let's see what you remember. Solve the following equations. So number one, we got ourselves an exponential. Do you agree? That's an exponential. It's got an exponent, right? How do you want to do an exponential? What's the inverse function for an exponential? Logs. Very good. What base is this exponential? So I will use a log with a base of 6. Okay. So you take a log with a base of 6 of this side, which means you need to take a log with a base of 6 of other side. You have to. Can't just do it to one. That'd be blasphemy. And the main theory I wanted you to get, that stupid worksheet that took 5 minutes before you left, was just to understand what? If you have a log base 6 and a base 6, what do? They cancel. Very good. So that is the main theme right there. And now the x is not in a log anymore. The stuff left over is x plus 5. So x plus 5 equals log base 6 of 7 right there. And after that, all you got to do is do what? Just with 5 over, right? No big deal. So x is log base 6 of 7 minus 5. That's my final answer. You cannot do the 7 minus 5. The 7's inside of a log, right? 5's outside. You can't mix them together. And don't go turn this into a decimal. This is exact. You know, just like you want to write the pi symbol for pi, you don't want to write 3.14 because pi is not exactly equal to 3.14. So avoid decimals at all costs. Questions over that? Anything at all? All right. Let's try number 2. Over here, now it looks scarier, but really we just got to do things twice. So I have an exponential 2 to the something, but the something itself is an exponential. It's 5 to the something. We're just going to unwrap it one piece at a time. First thing I'm seeing is this is 2 to the something, right? How do you get rid of a 2 to the something with a log with a base of 2? So we're going to do log base 2 of both sides. Log base 2 of this side. And then I must do log base 2 of that side. And at least now, this log base 2 and this base 2 cancel out. And what's left is what was in the exponent, which is another exponential. This was 5 to the x up here. So I still have 5 to the x left over. We got rid of one of the exponentials, but now we got this other one. But that's okay. We'll just get rid of this one. How are you going to undo this 5 to something? Log base 5, yeah. So I will do log base 5 of this side, which, as awkward as it is, over on this side means I need to do log base 5 of this. And of course, x equals that nonsense. Final answer is x is log base 5 of log base 2 of 100. And then we're all done, okay? So even though it was bigger and more complicated, still using the same fundamentals we've always done. Got exponentials inside of exponentials, okay. I'll use logs a couple times to get that thing solved. And then let's see if we can go the other way. Number 3 starts off with a log equation. Number 3 reads log base 2 of x squared minus 3x is apparently equal to 2. So how do you undo a log? With an exponential. What base should I use for my exponential? 2, right. Remember what you do? Where do you put the 2? Yeah, underneath of it. You make it a base. So this is the base raised to this side, which means on this side I need to have a base of 2 raised to that side. So you make both the sides exponents, which is kind of freaking weird, but that's what you do. And then by design, this base 2 and this log base 2 will cancel out, leaving me with just the stuff that was in the log, x squared minus 3x. Over on the other side, we got 2 squared, better known as 4. So now we have no more logs, nothing tricky. It's just back to old skills. It's a quadratic. What should I do with a quadratic? Set it equal to 0. Let's move that 4 over. So now I got an x squared minus 3x minus 4 is 0. And I'll attempt to factor. Does it factor? Well, let's see. X minus 4. X plus 1. Let's see if that's our jam. Did those numbers multiply to be negative 4? Yeah. Did they add to be negative 3? Okay, I think we're good then, aren't we? So the whole reason we're factoring is to see when the factors themselves are 0. If x minus 4 is 0, it's pretty obvious that that happens when x is 4. And if x plus 1 is 0, it's pretty obvious that that happens at negative 1 right there. So we are done with that. Want any questions on that? You remember all this stuff? Seems like you guys remember this stuff. I was kind of shocked all day when people actually remembered things. Like first hour remembered, fifth hour remembered. I'm like, wow. Well, good. I'm glad to hear that. That's great. All right, finishing up. Number 4, we have a log inside a log. It's time to freak out. All right, let's start unwrapping some logs. This outside log has a base of 2, right? Let's get rid of it with a base of 2. So we'll put a base of 2 here, which means on the other side I need a base of 2. And this base of 2 and that log base of 2 by design will cancel out. So now we're left with what was inside of that, which is another log. Log base 3 of x plus 1. And over on the right, we got ourselves a 2 to the first, or just 2. Yeah, so that's better. Less logs. Let's get rid of this log. That log has a base of 3. Well, let's put a base of 3 on both sides. And then on this side, the base 3 and the log base 3 will again cancel. And you're left with x plus 1. And over on the right, you got 3 squared, which is just 9. So it looks like x is 8 when you solve that. Those are the basics. Anybody got any questions over the basics before we move on? Nothing? All right. Let's dive in then. We'll do some LGs and we will get ourselves to work on the next stuff. It's not going to be that bad. Not that bad today. Here's your LGs. Oh, yeah. Learn how to solve simple logarithmic equations. That's kind of what we just did. There is one subtle thing to watch out for. There can be extraneous solutions. We'll talk about that pretty quick. There are some answers you can get out that just don't work. Same kind of thing we ran into with square root equations. Sometimes we solve square root equations and square both sides and introduce other answers, and they just wouldn't work. That. Not a lot. Not a lot. Hung around a lot. Spent time with my son. Hung out with my girlfriend. I tripped over. I was trying to walk barefoot. I don't walk barefoot ever, but I tripped over my toes and like crushed them, and my foot is black and blue now. Yeah, I might have broke it. So if you see me hobbling down the halls for the next 2 or 3 weeks, you know why. You're saying tripped while you're hobbling. Yeah. Well, I was drunk, so that's not true. No, I wish I was. It was just me being stupid. So I thought I could have some fancy story and lying to you all, but I just thought I'd be honest and like I tripped over the ground. I'm an idiot. Yeah. Ooh.
Yeah, so good that article. So I ran to the back over the immediately ran to the cabinet, broke my toe, had over heels for the rest of the week. So.
Ugh. Did it look all nasty? Mine looks all nasty. All right, guys, here's your homework. Let's go ahead and do this thing. First off, if you didn't do that stupid 5-minute worksheet before you go on a break, that's fine. That was your prerogative, but it's due today. Going back and forth real quick between the 2 forms. I'm sure 95% of you have that done. That's great. It's due today if you don't. And here's a new one, 8.2. Jot her down. Not due till Wednesday, 2 through 24. Even make sure you get the E written down. Don't want to do all of them. That would suck. And 27 through 36. Nah. I don't think anything today is hard, provided you follow along. If you just zone out and you're on your phone all class, then you go do your homework, you're like, what the hell is this crap? You know. But if you pay any attention and follow along, you should be just fine. All right, so 8.2, normal business. Tomorrow's a work day on that. Wednesday, it'll be due. Everything will be posted to Google Classroom after school now that the internet's finally back up, and let's get started. So section 8.2 is entitled Properties of Logs. There's 3 main properties I would need to talk about later. we're going to start off small and just practice solving some equations and watching out for the thing I alluded to, extraneous solutions. You got to watch out for that. All right, here we go. First off, don't write this down. This is dumb. What's a logarithmic equation? An equation with a log in it. So this is a logarithmic equation. It's got logs in it. It's an equation. It's a logarithmic equation. You don't need to know anything more besides that. That's kind of dumb. All right, let's practice one because we're kind of rusty. And I want to make sure, I'm not even worried about the logs on this one. I'm more worried about, do you remember what fractional exponents mean? We did a whole unit on it. Yeah. That was back before you tried, Jerry. You kind of just zoned out for that one. All right. Here we go, people. Uh-oh, the cheat's off the board. How are we going to do this thing? Let's get rid of the log. With a exponent, yeah, with a base of 4, right? Okay, so 4 to both sides. You're doing that so they cancel. You're trying to get to x. That's the point. So here's what x is. 4 to the 5 halves. And you might think you're done, but you're not, because there's more to do. Do you remember what a fractional exponent means? The top is just an exponent. Yeah, that's right. The bottom's a root. Very good. So I want you to try to do the root first. Forget the 5 for a second. It's just gone for a minute. Well, let's see here. Forget the 5. The 2 is a root, correct? Yeah. Yeah, that's exactly right. So you can think of it, do either one first, but probably do the root first. The square root, that's the 2 means, right? Square root of 4 is 2, right? So these two together is a 2. Now put the 5 back in. It's 2 to the 5th, which is 32. So a lot of your homework starts off with problems just like that. And you can't leave it as 4 to the 5 halves. You have to simplify it, know it's a root. That's the only thing tricky about that problem. But if you know that, you're okay. And remember the logic on that, okay, people? Let's see. Let's do another one. How about this thing right here? That looks kind of scary. Let's jot that down. Log base 5. Oh my. It's time to freak out. Everybody starts stabbing each other.
You told us to. So.
I did. You have permission. That'd be a great day. All right, thoughts, guys? Where should you start? What do you think you should do? Base 5. You hate logs, right? Well, let's get rid of them. Base 5, which means I got to do it over here. Oh, but that's pimp. Because on both sides, what happens? They cancel. Well, that's just convenient. That's exactly what it means. 2x squared minus 6, I guess, is 4x. We're out of the log world. Now what? What do I do now? Yeah, good job, guys. Let's move that 4x over. Let's set equal to 0. I'm going to write things in the correct order also. So there we go. Nicely done, nicely done. Okay, now what? You can factor this. Does anybody see something obvious you can do? Factor what? You guys always forget the first thing about factoring. Is there something they have in common? 2 goes LOZ. Factor 2 out. Oh, yeah. That's the good stuff. Now, can you factor this? I think it looks a little easier. Can you think of 2 numbers that multiply to be -3? -3 and 1. Do they add to be -2? Hell yeah, they do. So there we go. And the whole reason we're factoring is so we can look at each factor individually and see when it's 0. Well, here's 2. Is that 0? No, it's 2. Don't need to worry about that. Here's a factor. Could that be 0? Sure, if x is 3. So x is 3 is a possible solution. And similarly, the other one, when it's equal to 0, would be at -1. So I have 2 answers for this. Or do I? Yep. Let's jot this down real quick. I'm not going to redefine the term because we have done it before. But there are things that are extraneous solutions in log problems. Do you remember? This is kind of the rough sketch of the log. Do you kind of remember that at all? We talked about that briefly at the beginning of the unit. What can you not have in a log? Negatives or 0, correct. So only positives are okay. Do you agree with that? So the things inside my log better dang well be positive or else it ain't going to fly. Now let's see if these make the things inside the log positive or not. Let's start with 3. Ready? This was the thing inside of a log, correct? Okay, let's plug 3 in and see what we get when we do that. 3 squared is 9. 9 times 2 is 18 minus 6 is 12. Now, can I have a positive number inside of a log? Yes, you can. That's okay. What about over here? Well, 4, this is another thing inside of a log, right? Well, what's 4 times 3? That's positive also, isn't it? So is that okay? That's okay. This one's officially a pimp. Let's see about this jerk. I have a hunch this isn't going to work. Let's see if it does. Here we go. Oh, actually, right off the bat, look at this one. What's 4 times negative 1? Now, can I have a negative inside of a log? So this is not a thing. Extraneous. Cross it out. Do something to that. But you have to go back and check that the stuff inside the log, as many logs as there are, check them off. There's 50 logs. You got to go through them one by one and check. When you plug that number in, does it make the stuff inside positive? If so, you're good. Anything else? Chuck it away because it's just crap. We're clear on that one. Okay. Do you need to make a note about that or? You sure? All right. Getting a little cocky today. I like that. All right. Let's see what else we can do then. Let's try this one. This one has an extraneous solution. One's extraneous, one is not. Let's find out what's what. Jot her down. Log base 13. All right, here we go. Ready? Step 1, thoughts? Base 13. Love it. 13. 13. Bam, 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 bam. So, so negative 5x is equal to negative 2x squared plus 3. You know, there's nothing wrong with that. I could move the negative 5x over, but you know what? Thinking ahead, I like my x squared's positive for factoring. Do you like your x squared's positive for factoring? So as weird as it is, I think it'd be probably better to move these over there. You're not wrong if you go that way. It's just going to be hard to factor. Let's just move these over. That'll make it a positive 2x squared when you move it over. What's the 3 going to be when you move it over? Yeah. A lot of you think it's still 3. I don't know why. We move to the other side, it's negative 3. Is there something that they all have in common you can factor out? Well, shoot. Well, let's just try to factor it anyway. It's not x squared, it's 2x squared. It must have a 2x and an x. Do we agree with that? I don't think there's any other way around it. And the 2 last numbers still need to multiply by negative 3. Now, I'll tell you what it is. This is how it factors. Now, double check yourself when you do factor something weird like this. Distribute out real quick. That's 2x squared, right? This times this is negative 6x, but that's x, right? And negative 6x plus x is negative 5x, and 1 times that is that. So we're good on that. Now, also, don't go too fast with the simple ones. Anybody know what the answer to this is? What makes it 0? Anybody? It's negative 1/2. But a lot of people on your test, they just jump to a half or something like that, or write 2, or I don't know why it'd be 2. 2 times 2 plus 1 is not 0. But don't be afraid to take a second, set it equal to 0. It's okay to do a couple steps. I know it's blasphemy for a lot of people, but yeah, but it's officially going to be negative 1/2, like you said. And this one over here, we always just jump to its 3. But again, what you're always doing is setting equal to 0 and solving. So I have 2 potential answers here. Potential. Could be extraneous, right? Well, let's go back and find out. You might want to get a calculator out because I know you don't like to work with fractions, right? You hate fractions? Wusses. Well, here we go. Let's check them. Ready? I'm gonna do the fraction first. Ready? Negative a half. Does it work? Let's find out. What was inside the logs? This thing and that thing, correct? Plug negative a half in, see if it makes the things inside the logs positive or not. What's negative 5 times negative a half? It's a positive something, would you agree? Positive 2.5, but it's positive. Positive okay? Positive okay. And this is less obvious. Let's try to do it in our mind. Anybody know what a negative a half squared is? A negative half times negative a half. Positive a fourth, would you agree? Times negative 2, that'd be negative 2/4, or negative 1/2, plus 3 is positive, isn't it? So does this make both of them still positive? That one's cool. So that one's an official answer. Well, let's see how this one goes. 3, right at the bat. Try to plug it in there. What do you get? Negative 15? That ain't no good. So this is crap. Cross it out. Hate it. Taunt it. Spit on it. It's all okay. So far, so good, everybody? All right. Let's keep her going then. So the second half of today is this. Take a minute and copy down these 3 properties. They're brand new. Yes, they are. To you. They've been around for centuries, but
They've always been around.
ooh, I like that, Derek. I like that a lot. You know, you got all these rules for exponents. Power to a power, you multiply. X squared times x to the third, you add your exponents. If you divide, you subtract it. There's a lot of rules for exponents. And since logs are just the inverse of exponentials and exponents, you would assume that there's a lot of rules for logs too, and there are. These 3 in the box are the highlights. Definitely want to write them down, and definitely when you're starting off, look at them religiously when you use them to make sure you don't jack them up. The first rule is called the product property. And what that says, if you have a log of 2 things multiplied together, say x and y, so it could be 4 and 3, it could be any numbers, doesn't matter. And what you can do is you can break it up, you can expand it, is a word I'll use a lot for this, into 2 other logarithms. There's sum. So log, any base at all, this works for any base. If you have a log of x times y, you can call that log of x plus log of y. If there's a rule for multiplication, I'm sure there's a rule for its sister division, and there is. Quotient property. If you have a log of something divided by something else, say log of x divided by y, then it's the log of x, but minus the log of y. Basically, when you see a fraction in a log, the ones that are on top are positive logs, and the one on bottom are negative logs. No matter how complicated the fraction gets, and we will build up more complicated things than what today's lesson is. And you got that right there. And the bottom one, probably put a star by that. That's my favorite. If there's one property I want you to get from logs altogether, it's this. If you take a log of an exponential, but notice this is the first time this hasn't happened for you guys yet. Do these bases at the bottom match? This is base B and this is base X. Are they the same base? No, they're not. So do they cancel? No, they don't. But there is some magic, and I want you to really understand what it is. If you have a log of an exponential, even if they don't cancel, look what the exponent did. The exponent was inside the log first, right? Now it's outside the log. That is huge. If you take a log of an exponential, then the exponent comes out whether the bases cancel or not. So down there you have that right there. So as a quick dry run, just to practice these real quick. You got them written down? You got them written down? All right. Here's your pop quiz then. This is something really dumb. Log base 7 of 3 times 4. That's 2 things multiplied together, correct? I could say log of 12, but the point of this is to break it apart. Do you have one of your properties that says log of something times something? Product property. What's that say? 3. Mhm. You got it. That's all there is to that. If some jerk said log base pi, don't let me scare you when I use a pi. Of 121 over 5, which property is this one when you're dividing? Quotient, which means log base pi of minus, very good, of 5. Outstanding. Yes, good job, everybody. So far, so good. Okay. Now here's a weird one. Natural log. We haven't talked about that yet. It's just a log. But let's say I had 4 to the 5th. Anybody know what base this is? It's 8, 4. I kind of alluded to it before break. If you remember, I'm impressed. I did tell you, we haven't formally done it, so if you don't know, that's okay. It's log base E. And remember what E is? Now, 2 point something, is that the same as 4? Are these the same bases? Heck no. So there's not much you can do with them, correct? Except, what's the very last property you wrote down? Power property. Even though these don't cancel, what can happen is the exponent can still come out in front. This is what logs are good for. They get the exponent out. So this is 5, bring the exponent out. And then what's left? Natural log of 4. And even though you don't know what natural log is, just some stupid logs, so don't worry about it right now. Okay. There's a quick example of all 3 of those. You okay on those? Yeah? Let's try some examples of those from the book. So this is very much the speed of what they're going to give you. You probably want to write this one down because they're kind of weird problems unless you've seen it done once or twice. If you've seen it done once or twice, it's no big deal. You're going to use these properties to expand your logs out into smaller pieces. But they also give you this weird bit of information on all these problems right at the bat. They tell you that log base 3 of 5 is about equal to 1.465 right there. And they say use that information to approximate the value of log base 3 of 405. Okay, ready? Got your calculators? Get your calculators out if you don't have them. We're going to need some calculators. We're just going to have to hunt for some numbers that go into these things. What base is my log? Boy, it'd be nice if I could find 3's inside this thing. Would you concur? Why don't you take your calculator and divide by 405, divide by 3, see if it's pretty. All right. Sounds good. Let's keep breaking things down more and more and more until we can't do it anymore. It'd be nice if 3 went into 135. Does it? Can we find out for me? Is 3 going to 135? 45 times? Okay, so I can call it 135 of 3 times 45, right? Boy, it'd be great if 3 went into 45. Oh, yeah. All right. So you tell me this is 9 times 5. And while I'm at it, 9 is just 3 times 3, correct? So in a really roundabout way, what have I figured out is buried inside a 4 to 5? 4 3's, correct? And a 5. Better known as log base 3 of 3 to the 4th times 5. So we basically factored that thing down as far as we can. And what was the magic number we kept trying to look for? 3's? Because this is log base 3. Now go back to your properties real quick. I see right off the bat 2 things multiplied together. Do you? Product property. So we're going to break it up. Tell me what I should write here. Log base 3 of 3 to the 4th. Plus log base 3 of 5. Very good. Very good. Very good. Outstanding. Any questions over that property we just used? Okay. I see something that cancels out. Do you? Oh, yeah, there's a log base 3 and a base 3. Good thing I was hunting for 3's, huh? So those cancel and just leave me with 4. Now we got this leftover jerk. Log base 3 of 5. But look what they gave you right at the start of the problem for apparently no reason. They said log base 3 of 5 is about 1.465. So instead of writing log base 3 of 5, they want you to write 1.465. And then the grand total is going to be 5.465. So that's the kind of thing they want you to do on this problem. They want you to take your numbers and break them down as far as you can in terms of the base, if possible. Then use your properties to expand it out, and some things will cancel, some things won't. And that's pretty much all there is to that. Let's try another one just like that. Sort of like that. Down there at the bottom, they're saying log base 8 of 5 is about 0.774. They're saying use that information to estimate the value of log base 8 of 320. Log base 8. Maybe I should hunt for 8s that go into this. Could somebody take 320 and divide by 8 for me? Okay. Can I break it down to 8s anymore? That's an 8 and a 5, isn't it? So how many 8s are all together? 2? So I'll say 8 squared times 5. Everything making sense so far? All right, same exact property now. Let's see here. Let's go ahead and break it up. I think, again, we're calling on the product property again, right? Two things multiplied together. So that's just log of one of them plus log of the other. One of those is pretty, one of those is not. Which one cancels? A, B, A, B. That's going to cancel, isn't it? So that's just 2. So I got a 2 plus this log base 8 of 5 thing, but they told me log base 8 of 5 is 0.774. So I guess the answer to this particular problem is 2.774. Yeah. Yeah, that's another way to go. Yeah, you don't have to start. I mean, why did they give you log base 8 of 5? Because guess what goes into this? 5 also does. So you could have right off the bat broken this into a 5 times, guess what? Like you said, 64, right? But then again, 64 is, so I get back to the same spot, don't I? So yeah, either way you want to go. You can start trying to divide by that thing. You're trying to hunt for the things in the base. That's fine too. Whatever you guys want. Nice job. Nice job. All right, here's another one. Let's try this thing out. Ready? It looks scarier. It's got a fraction. Actually, fractions aren't bad with logs. I know how much you guys hate fractions, but that's okay. So write down the problem at the very top. This one's telling you that if log base 3 of 5 is approximately 1.465, and try to find log base 3 of 9/5. Okay. Right away, you got something divided by something else, correct? What property pops to mind of the ones you wrote down? We have one divided by the other one. Quotient property. What's the quotient property say? It's the log of the top minus the log of the bottom. So log base 3 of 9 minus log base 3 of 5. I wonder why 9. Why did they choose 9 for this problem when your log has a base of 3? Because it's 3 squared. That's exactly right. So let's rewrite the 9 as a 3 squared. Because then the log base 3 and the base 3 will cancel out. Leave me with just the exponent 2. So I have 2 minus the log base 3 of 5, which they told me was about 1.465, which gives me, when you subtract it, about 0.535 is my final answer. Any questions over these? Are pretty straightforward, I think. Maybe the hardest part is factoring the stupid numbers. You know, I got 420. I got to figure out what goes into that and all kind of stuff. Let's try this bottom one. Speaking of pain in the butts to figure out what goes into it. Bottom one on the board says, use the fact that log base 6 of 5 is approximately 0.8982. Use this fact to come up with an estimate for what log base 6 of 5 over 1296 is. Right off the bat, guys, what property jumps to mind? I think quotient again, yeah. So let's go ahead and do that. Log of the top minus, right? Quotient property, yep, minus the log of the bottom. One of them they gave us. They told us what log base 6 of 5 is, right? I bet you the other one has some 6's buried in it. Why don't you find out? Take your calculator, start guessing. 6 squared, 6 cubed, 6 to the 4th, 6 to the 5th. Is this 6 to something? I hope. Oh, to the 4th. Man, that's freaking awesome. What a coincidence that 6 raised to a power, because now the log base 6 and the base 6 cancel out. So we're left with log base 6 of 5, which they told us is about this, 0.8982. And then when those canceled out, we just had a 4. Is that fair? Yeah. And when you subtract them, you get negative 3.1018-ish. And we're done with that problem. Anything too hard today? I don't think so. As long as we kind of get the basics of the properties down, we should be just fine. And lastly, let's go ahead and do one example of the last property. We haven't really used the power property too much, so a couple more examples and we'll call it a day, then you got some time to work. Here's the last couple. Up here, use the fact that log base 2 of 6 is 2.585 to approximate the value of this log. $12.96. My gosh, that's a big number. Didn't that just come up? Oh, what a coincidence! It's 6 to the 4th. Well, let's write a 6 to the 4th then. So let's see. Log base 2 of 6 to the 4th. But those bases aren't the same, are they? That's okay. What's that last property tell you? Power property thing. Even if the bases aren't the same, it's okay. What can the exponent do? It can still come out in front. I'm really going to hit that hard. You see any logs with bases that match or don't, that exponent comes out in front. So this is the same thing as 4 times, and what's left if the exponent comes out is just log base 2 of 6. Well, what a coincidence. They told us that log base 2 of 6 is approximately 2.585. So this is 4 times 2.585. 0, carry the 2. 3, carry the 2. I think that's it. Somebody check me, though. I really don't trust my mental math on carrying. All right, sweet. There we go. Cool. Very last one. Why don't you see if you can do that on your own? Down at the very bottom of the screen is the same kind of thing. Log base 2 of 3. Jot it down. See if you got your check in order. Log base 2 of 3 is approximately this. Write down. And you're trying to find log base 2 of 243. 243. Anybody recognize that number from their tables? It's something to a power. I wonder what. I don't know. Get your tables out if you need those old tables for a list of things raised to powers. Anything raised to a power that's 243. Probably. 3 to the 5th? Okay. There's your start. Call that thing 3 to the 5th and see how it breaks down from there. What's the only thing you can do on this thing since the bases aren't the same? I don't know. The only thing you can do is bring an exponent out, right? So did everybody do this next step? They brought the 5 out. Did you do that? Okay, then you are in good shape for today. And then this is left over, correct? And you knew what that was, right? So 5 times this is what? Oh, I'm not doing it. Don't make me think. Thank you very much. So there's our final. Did you get that? Did you get that on your own? Then you are in good shape. So that's it, okay? You only got a few minutes left, so probably not enough time to start on your homework. That's okay. We'll have a work day tomorrow. Just don't forget everything. You guys did a good job retaining things over break. Thank you very much for that. Makes me happy when we don't have to start from scratch every time. But don't forget that 8.1.5, that rinky-dink worksheet is due in case you haven't turned that in. And 8.2 we'll work on tomorrow.